A Vernier Callipers is used to measure the length, thickness, diameter, and depth of an object and to measure the internal and external diameters of a hollow cylinder. This instrument can measure dimensions up to 0.1 millimeter or 0.01 centimeters. The two scales on the Vernier Callipers are the main scale and the vernier scale. The main scale is a long, thin steel strip with a jaw J1 at one end and is graduated in millimeters. The vernier scale is a graduated movable steel strip with a jaw J2 that can slide over the main scale. Generally, the vernier scale has 10 divisions marked on it. The vernier scale can be fixed at any position on the main scale with the help of a screw. The jaws J1 and J2 are parallel and projected on either side of the main scale. The lower jaws are called the outside jaws. They are generally used to measure the length or thickness of a given rod and diameter of a sphere or a cylinder. The other jaws are inside jaws and are used to measure the internal diameter of a hollow cylinder or pipe. There is a thin, long strip T1 attached to the vernier strip at the back of the main scale. This is used to measure the internal depth of a hollow tube or cylinder. The object to be measured is placed in between the lower outside jaws. Whenever we use a Vernier Callipers, we need to first find the least count and the zero error of the instrument. Least count of an instrument is the smallest measurement that can be recorded accurately with it. To know the smallest measurement, we must first find out the number of divisions on the vernier scale and the value of one main scale division. In this case, they are 10 and 1 millimeter respectively. Least count is then given as the value of one main scale division over the number of divisions on the vernier scale. This will be 1 millimeter over 10, which is equal to 0.1 millimeter or 0.01 centimeters. Now the zero error. Sometimes, when the movable jaw is brought in contact with the fixed jaw, the zero of the main scale does not coincide with that of the vernier scale. This is a mechanical error and is referred to as the zero error of the Vernier Callipers. Depending on the position of the main scale, the zero error can be positive or negative. Consider these three Vernier Callipers A, B, and C. In Vernier Callipers A, the zero of the vernier scale and that of the main scale coincide. Therefore, this Calipers has no zero error. In Vernier Callipers B, the zero of the vernier scale is to the right of the zero of the main scale. This Vernier Callipers is having a positive zero error. To get the zero error of these Vernier Callipers, we first note the division of the vernier scale that coincides with any division on the main scale. In this case, we have 4. We then multiply this with the least count of the Vernier Callipers. This gives us 0.04 centimeters. The readings taken by these Vernier Callipers will be greater than the actual measurement by 0.04 centimeters. The Vernier Caliper C is having a negative zero error. To get the zero error here, first we note the division of the vernier scale that coincides with any division on the main scale. In this case, it is 6. We subtract this from the number of divisions on the vernier scale. Then we multiply this difference with the least count and assign a negative sign to the final value. So here we shall have 10 minus 6 times 0.01 centimeters. That will give us negative 0.04 centimeters. The readings obtained by these Vernier calipers will be less than the actual measurement by 0.04 centimeters. After finding the least count and the zero error of the Vernier calipers, we calculate the readings using the formula. Observed reading is equal to main scale reading plus the coinciding Vernier scale division times the least count. Then we calculate actual reading is equal to observed reading minus the zero error. And remember, zero error can be positive or negative. For example, let us determine the length of this rod. The first thing is to find the least count of the Vernier calipers. And we know our Vernier calipers has a least count of 0.01 centimeters. Then we check if the Vernier calipers has a zero error. In our case, it appears to have a positive zero error. We calculate how much that is. The coinciding Vernier scale division is 6. So we multiply that by 0.01 centimeters to get a zero error of positive 0.06 centimeters. Now we are good to go. We fix the rod in between the outside jaws J1 and J2. We note the main scale reading. It's 4.6. Then we note the coinciding Vernier scale division. It is 3 in our case. We calculate the observed reading using our formula. 4.6 plus 3 times 0.01 will give us 4.63 centimeters. And then we calculate the true reading. 4.63 minus the zero error, positive 0.06, and that gives us 4.57 centimeters.